Light is an electromagnetic wave. Electromagnetic waves traveling in the same direction oscillate in lots of different orientations. Some sunglasses reduce the glare from the sun by polarizing the electromagnetic waves so that only waves oscillating in one plane reach our eye. How does polarization work? To understand this, we need to recall that electromagnetic waves are transverse waves with an oscillating electric field at right angles to an oscillating magnetic field. Explain that transverse waves can be polarized and that this means the oscillations are all in the same plane. Explain that two polarizing filters with perpendicular planes of transmission will completely block a transverse wave. Electromagnetic waves are transverse waves. They have an oscillating electric field at right angles to an oscillating magnetic field, and both these are at right angles to the direction of propagation. Because the magnetic oscillations are always at right angles to the electric oscillations, we can simplify things by just talking about the electric oscillations. Usually, a beam of visible light waves contains waves with the plane of the electric field oscillations at many different angles. But if the electric oscillations are all in the same plane, then the light is said to be plane polarized. If you imagine looking directly towards the wave as it approaches, the electric oscillations would be vertical. So we say this electromagnetic wave is plane polarized in the vertical direction. This wave is horizontally plane polarized. When there are waves at lots of different angles, the light is said to be unpolarized. Microwaves are also electromagnetic waves, and so can be polarized. When this 3 cm microwave transmitter is lined up with the receiver, microwaves are detected. But no microwaves are detected when the receiver is turned by 90 degrees. This shows that the microwaves are plane polarized. When a metal grill is placed between the detector and the receiver, no microwaves are received. When the grill is turned by 90 degrees, there is a signal. The grill is acting as a polarizing filter. It lets the polarized waves through in one orientation, but not in the other. How does it do this? Microwaves are produced by accelerating electrons. For example, a changing electric current in a metal rod will radiate microwaves that travel at right angles away from the rod and are polarized parallel to it. When they strike metal rods that are aligned with the transmitting rod, the waves cause changing electric currents in the metal and are absorbed or reflected. None are transmitted. But if the grill is turned 90 degrees, the transfer of energy from the microwave oscillations to the electrons in the metal is very weak, so the waves continue to the detector. Many people think that the waves can slip through the gaps in the grill, but that is not what is really happening. Visible light from a lamp or the sun is unpolarized. Polarizing filters are made from some crystals or from Polaroid, which is a plastic that has been stretched as it's set, so it contains lines of long chain molecules. In these materials, the light waves cause the molecules to oscillate, and so energy is transferred to the material. The light waves with their electric field oscillations perpendicular to the lines of molecules are unaffected, and so these waves pass through. When two polarizing filters are aligned, light passes through both of them. When two polarizing filters are crossed, light cannot pass through both. This is called extinction. To explain this, think about the oscillations. The first filter absorbs the horizontal oscillations. The second polarizing filter is at right angles to the plane of polarization of the light, so it absorbs the vertical oscillations, and no light is transmitted. Electromagnetic waves are transverse waves with an oscillating electric field at right angles to an oscillating magnetic field. Electromagnetic waves can be polarized with a filter. Polarized waves have all the electric oscillations in the same plane. A metal grill acts as a polarizing filter for microwaves. Adding a second polarizing filter perpendicular to the first causes extinction.